arrive at the destination. So you are given a city that consists of 0 intersection numbered from 0 to n minus 1 with all the bi-directional roads between some intersections. Okay, so the inputs are generated such that you can reach any intersection from any other intersection, and there is an at most one road between any two intersection. That means the graph is completely connected. So you are given integer and 2D the roads, okay, the edges, there is edge time, okay, time takes to travel from u to v. You may want to know how many ways you can travel from the from 0 to n minus 1 in the shortest amount of time. Okay, not the time but the number of ways to reach that destination, not in the shortest amount of time. Okay, since the answer can be very large, we need to modulo it with this value. Okay, so the number of ways to reach at the destination. Okay, let's see. So if we have some source node and we have some destination node, then from source to destination, so I will have some intermediate node, and from here I could go to destination node. So can I say the number of ways to reach a destination? So suppose the shortest amount of time is t. So can I say for the destination node, if I have multiple ways to reach a destination node, so can I say if the f of the destination node in time t, the number of ways to reach a destination node in time t is equal to the number of ways to reach at their neighbors plus the time difference is t1, t2, t3, t3. That means sigma of all the neighbors, so all the nodes v belonging to the neighbors of u, and the time to reach at v in time t minus distance to reach the edge between d and v, where v is this one. So time to reach at v, but how to find this value? So that means my function depends in these two parameters. So dp, can we say it is a dp? If for every node I maintain this value, the time to reach at that node from the destination node only. So from the destination, if I reverse this, is it directed or undirected graph? Okay, undirected, so no. So can I say, so from destination I know the time t, the final time, the shortest amount of time to reach at this destination node. Let's write it as d is t. Okay, so from here go to all the nodes, go to all the edges, go to all the neighbors of d and write their values as the time to reach at this node. Let's say n1, n2, n3, n1, n2, n3, t1, t2, t3, right? So time to reach at n3, let's say, will be t minus t3. How many ways are there to reach at n3 in t minus t3? Similarly, how many ways are there to reach at n2 in t minus t2? How many ways are there to reach at n1 in t minus t1? So if I add all of these, that will give me the time to reach at d in time t, right? Yep. Can we solve it in dp? So dp of d and t will be equal to dp of n1 t minus t1 plus dp of n2 t minus t2. Okay, so both the states, what's the ranges? Oh, you cannot memorize this. You cannot create a 2D matrix t and n. That means this cannot be a dp. But what is this? So dp can be applied if even if we don't have this value, right? Shortest amount of time. I mean dp will be the generic solution. So shortest amount of time, that means t is fixed. So we might not need that dimension to store that. Is it? Let's see. We might not need to store capital T because it is fixed in the beginning, right? So what if I can say that from this node I need to go to these intermediate nodes and I need to go to this node. This is my source, this is my not source, let's say it is u. So from source I reached at u, and from these nodes I am going to this v, and v is somehow going to the destination node, right? This is my source node and I can reach it here. These are direct edges, let's say, not through any other vertex in the between. This is direct edge. Okay, there is direct edge from here to here, direct edge from here to here, and let's say there is an edge from here to here also. Now, so if I reached at u and I know the time to reach u is tu. Okay, so time to reach at u from the source is, let's say, ts. I can always get that from Dijkstra. The shortest amount to reach at u is ts from the source, and from u, then from u, and also if I know the answer for u, that means number of ways to reach at u in time ts. Reach at u in time ts, if I know the answer for this node. Let's say if I know the answer for this node. Okay, so time to reach, what do I know? I know the time to reach at u from source in time ts. So I think we will know it for all the nodes, right? Because from source I can run it extra, which will give me the time to reach at all the nodes u from the source in time ts. Okay, I know that answer. So when will I go to this node? So can we say that the number of ways to reach at this, so if it is t1, it is t2, it is t3, t4, t5, t6, t7. So number of ways to reach at this node from the u node. Okay, so number of ways, I know I need to find the number of ways to reach at this node. Let's say it is x, it is y, it is z. So number of ways to reach at x node, it will be, okay, I would need to find this one also, right? No, from ts, so I will go to x node if and I will, so you, I'm thinking of the d push type dp type kind of thing. So if I know the answer for u, can I update the answer for these neighbors x, y, and g with the value of u? Yes. So from u I will go to x if and only if this distance, that means from x I can reach to destination in t minus, so total time is t minus, so ts is the time minus ts plus t1, right? So the destination, so total time is capital T minus ts plus t1. That means in this time, in this amount of time, if I'm able to reach a destination, then only I can say that the number of ways to reach at x in time t dash, which is ts plus t1, is some value such that in the remaining amount of time, that is t minus t dash, I can reach to destination. I think we need to store these two values for every node, the distance from source and distance from, so if I come from source to that node, I can find the Dijkstra, and then again from that node to the destination I need to find the Dijkstra. So maybe reverse Dijkstra. Okay, so for every node, so this definition is now changed. So time to reach at u from source, from u, time to reach at u from source in time ts, such that I can reach to destination node, such that I can reach to destination node in time t minus ts, right? So if I know the values, I need to store these values. So my dp will be this one. So dp of u is nothing but, so my dp of u, so dp state is this one, time to reach at u from the source node in time ts. Okay, ts will also be required, or I can reach to destination in time t minus ts. That means from the source node, so source will always have 0 and the distance is t. So first distance from source will be 0 and distance from destination will be t, the shortest amount of time. So it will have these 3 nodes, let's say, in the first case. So from source I can go to this in t1, I think, yeah. So solve this one. So calculate d1, which is the distance from source, and t2 is equal to distance from destination for each node. So for all nodes u, calculate this one, d1 d2, and then go start from source, to visit the neighbors. So okay, I visited this neighbor. Can I update the answer of this? Yes I can, if and only if, so because we know this value, right? So d1 I know for this one, d1 I know for this one. Can I go from source to this node? Yes, if and only if the t minus d2 is equal to d1. Is it? So if t minus d2 is equal to d1, so then that means if the number of ways to reach here is x, then the number of ways to reach here will also be x. The number of ways to reach here is x, then it will also increase by x, right? So it will also increase by x. Suppose this edge is also doing something like that. That means I can reach in some weight, so that means it will increase its value by, suppose x1, it was x1, it was x2, so it will increase its value by x2. Is it so? Let's dry run this solution or directly code. Let's code. I think it will work. Okay. We need to find the count paths, and we are given the n and the edges, right? Count paths. Count paths. And then vector of roads. And then vector of roads. Okay. So I need to first apply Dijkstra. So let's say get shortest path from the node source and pass the, okay, I will have some adjacency list, right? So it will give me what it will give me from that source node to all the other nodes. That means vector of integers, the distance of all the nodes. I need to find it 2 times. Okay, so let's have the graph. Let's create the graph. Fit from 0 to n minus 0 to n minus 1. Fine. Okay, go to all the road. Over the roads. Go to all the road. So from uv time, that means it will be a pair of to end. So road, that means adjacency of road of 0 dot slack make pair of road of 1. And what's the edge, what's the weight of that edge? So this will be a undirected graph. To add both the edges from 1 to 0 also. So add a weight with weight this. We have the adjacency graph created. So vector of into d1, let's say distance from source is nothing but get shortest path from 0 and n minus 1. So numbered from this. Okay, you want to know how many ways? So 0 and n minus 1. Okay, 0 and adjacency. So we have this. We have distance from destination is equal to get the shortest path from n minus 1 with this adjacency list. Distance from source, distance from destination. After I got these two, let's have our answer. So we answer is 0 and suppose I know the answers, so distance of a node from the source from the destination. So d1 d2 I know. So what was this value? So we need to find, do we need to find, so if I know d1 d2 for every node, d1 d2 for every node, then start from the source node and go to all the edges. So source answer is always 1. That means the number of ways to reach at source in time 0 is 1, right? That means it can propagate its number of ways to its neighbor, its first neighbor, if and only if that neighbor, from that neighbor I can reach to d minus d1 ways, right? From that neighbor in d minus d2 time, right? So first neighbor suppose has d1 d2, then I will go from the source to this node if and only if from this node I can reach to my destination node in d minus d1 time, d minus d1, that means it should be equal to d2, then only go to that node, then only increment that number of ways from here to here. For this one also similarly. And why would I visit a node which is already minimum distance, right? So I would need to have, in which order should I visit? So because if I visit a node, it might be possible I visit it twice, 2 times, but because there might be 2 paths leading to this node, so that x1 plus x2, right? So suppose this is pushing answer x1, it is pushing answer x2. I need to know the answer x1. That means x1 should never be visited again, x2 should never be visited again once I pushed its value to its neighbor. Some kind of queue, right? Some kind of queue. From that we can pop that node, then okay, BFS kind of thing. But ordering is also matter. Ordering also matters. That means not the normal queue, it should be priority queue. Okay, so which one should I pick first? Is it same? Because if I write them in the order of the distances, order of d1, if it is d1 and the node, let's say u, I need the number of ways also, right? So they will update number of ways of that v will increment by number of ways of u. Yeah, so the order should be in the order of distances, not the number of ways. Because if I know that if I already have reached at x1 in shortest amount d1, then there is no point to visit that node again. That means this node's value is finalized, right? Then only I can push its value to its neighbors. Okay, it makes sense to not visit this node again. That means sort it using their distances from the source, and second value will be the node which I am picking where I am standing at. From there go to the neighbors, right, and do the update of this. So we'll need a number of ways also, number of ways vector also. Okay. So vector of integer, number of ways, right, which is to reach, so to pre-value as 0, number of ways. That means, so let's take a set of pair and sort it using the distance. That means st dot insert make pair 0 will be my distance of the, and source is always 0. From 0 to n minus 1 I'm going, right, while my set is not empty. While my set is not empty, let's pop that value. P is st dot begin and remove it from the particle. The set dot remove it and go to its neighbors. So that means I am standing at this node. U is p dot second, second, and this is the distance to reach is the p dot first. Go to all the nodes or to neighbor over the adjacency of u. Okay, so we pick that, go to neighbor. We have v is what, neighbor dot first, and the time is time t is neighbor dot second, right. So I will go to this neighbor if and only if v is a neighbor, if and only if no. Do I know capital D? Yes, capital T should be distance from source and shortest time is nothing but shortest time is distance from source of n minus 1 node. Shortest time, or capital D, let's write it as capital D. Is the distance from source of this node n minus 1. Okay, we have the set, we'll also need number of ways, right. So number of ways of 0 is always 1. The number of ways to reach at 0 in 0 amount of time, such that in the remaining amount of time I can reach to destination node, is always 1, right. So insert 0, this is the node, this is the distance of that node, Vector of integer, number of ways, okay, it is the distance. Okay, let's pick the first node and this is my node where I'm standing. I also know the number of ways to reach here, right? So from here I will go to V if and only if, what did I say, the T, that means the time, that means distance from neighbor, so distance from destination if and only if the distance from destination of this node V plus distance from source of this node U, or directly write distance of this node from V, distance from shortest distance from this, distance from source, no, distance from source to U plus T1, because we might have got to V from some other path while calculating the distance from source, not using the T path, right? Yeah, it is required, so it is, so this equation is correct. 2U plus T is equal to T. I think this is correct, not the distance of V, direct distance from source of V is not correct. So that means I am taking this edge. That means, so what happened, so at this point I'm standing at this node, I'm standing at this node U, and time to reach is distance from source to reach at U, so there is a path of length T to V, and from V, for V also we know the distance from destination of this node V, right? So if I can reach to this in some time, I don't know which path I'm taking, okay fine, plus if I'm taking this path, so T plus the distance from source of this path should be equal to the shortest path, then only we can say whatever the number of ways I can reach from source to this node U, that in that many ways also I can reach to V by using this path, right? Yeah, so we can propagate this value, that means number of ways to reach at V will increment by number of ways to reach at U. Is it correct? Yep. Number of ways to reach at this incremented by this. And shall we push V also in the queue? If this is the way, then only I am taking V, right? So from U I came to V and calculated the number of ways to reach at V, incremented the value. U is removed from the set. So distance of, what is the distance of V now? Do we need to process it here, or so that means I have taken this node V. What if I don't reach to that node which was, so suppose some node V is not satisfying this condition, so shall we push that node also in the queue or not? Or not? Why would I push that? Because I should not, right? Or should I? So where should I put V? So the condition to put V, Okay, so this is the way, this is the number of ways to reach at V. Increased, that means, okay, so from other path also it can reach from 2 3, suppose 5 neighbors, in that 3 are satisfying this condition, 2 are not. So will those 2 other node will ever be in the set? So suppose, so if I don't put them, what will happen? Will any other node put that? Since in the set I am the in the set U is the smallest node, so any other node which will be visited later will always be will always have greater distance than currently you have, right? You node have, and you node have plus the time, so that you that might be smaller, right? Okay, you is the smallest node to reach, so U is the smallest node, U is the shortest node, shortest time node that can be reached till now. From U, if I'm not visiting a node V, will I ever visit that node again? V can be visited, right? So it does not matter, or does it? Let's try it this way. If V satisfies the number of ways to reach at V, okay, so can we push V? Can we push V? So suppose if I push V directly here, then those nodes might be left even if I pick them. So let's pick them. So if the distance to it sort, so what's the current distance? That means distance from source to reach at U, distance from source to reach at U plus the current distance, which is P dot first, no, which is T. So if distance is less than the current distance of V from the source, let's come to it later. What's the question? Which V's to put? Let's complete this one, get the shortest path from source for this graph. So we will have a set of here the distance and node st and st dot push st dot insert make pair of the source node as the distance 0 and source node is this one, and while my node begin and st dot raise st dot begin, shortest distance we need, right? So we would have to vector of integer the distance of each node, which is nothing but adjacency dot size, and every node has infinite distance. You can say distance of source is nothing but 0, or it is infinite. Need to define that. So infinite is 5, 6, 7, 8, 9. Let's say 118 plus 9. Long int, convert it, so it is infinite. So distance to reach, let's define that long is L. So vector of every node has infinite distance, and pair is of type, so this will be the distance and this will be the node. So 0 source, distance of source is 0, and push it inside the set. Else it is not empty. Get the node. So we have the node u, which is p dot second, and the distance we always know, distance of u. Go to all the neighbors, to neighbor or adjacency. I think this will be a pair of intent, and it will be which node I'm going. It is neighbor dot first, and what's the time? It will be neighbor dot second. No, from here to here. If I want to go to this neighbor from u to v in time t, then to check if the distance to reach, the current distance to reach at v is greater than the distance to reach at u plus this time. That means we need to update this. You can say distance to reach v is distance to reach at u plus t, and push it inside the set, which is nothing but distance to reach at p from node b. But if it already exists in the set, we will do set if st dot find that value is not equal to st dot n, then st dot erase. Need to have st dot find that value. Which value? This pair, right? So it will give me, and finally return the distance vector, which is a so distance of each node from the source node. Distance is 0, distance of source is 0, and while set is not empty, p is st dot begin, st dot erase. Go to other nodes u, and this is u, and from here I can go to v, which is neighbor dot first, and time is this second one. If that distance is greater, if current distance is greater than u plus t, then update it and insert it, otherwise delete it if it is already existing, and return the distance. It will give me the shortest path. So let's have everything in integer, or long will work. Long, every time is 10 raised to 9, and how many nodes can I have? 200, so 10 raised to 11 might be the number of edges. So 10 raised to 9, if everything is 10 raised to 9, till 10 raised to 11, which will not fit inside the integer. So maximum distance can reach greater than int max. Okay, long int is fine. So vector, it will give me, let's say, paste it here. Just the shortest path. Get the shortest path. Okay. Will it work? So get the shortest path from the source for this graph. Okay, actually pair of integer. So vector of L distance infinite and set is t. Insert 0 and source. Well, set is not empty. P. Erase u neighbor vt. If that is fine, that is fine. Okay. So give me all the distances and return. Okay. So this one and count paths. Let's see. Count paths. So we have the adjacency, create the graph. We have the adjacency for every road, inside roads, okay, from 0 to 1, 2, 1 to 0, 2. Create the graph. Then apply the Dijkstra to get the distance from source, distance from destination. Okay, 0, and get shortest path from here. We need to find the number of ways. Okay, so it is LL, it is LL, it is LL, right? So okay, I need to define mod also. So constant mod is 1 2 3 4 5 6 7 8 9 plus 7. 1 in 9 plus 7 we can write. And convert back to int. Okay. Distance from source, distance from destination. So number of ways. So t I have and set. Total time, the required minimum time to reach at this is n minus 1, and get the set, insert 0. 0 is the distance to reach here, and 0 is the source node. Okay, source node, and number of ways to reach at source node is 1. Now apply our DFS. Now while set is not empty, what we'll do? st.erase. Let's think. Do we need to push this v or not? So what is it? I know the answer for u from here. From answer from u, I need to go to v. And I know this time is t, and so, and I also know that the time to reach at destination from v is nothing but total time minus t minus, suppose, distance from source of u, this one only, right? So distance So time distance from destination, so which is equal to, it should be equal to distance from destination of v. So if we can say distance from destination to reach, distance from destination to v is equal to plus this time plus this time, so this time plus this time plus this time is equal to t, which is what I've done here. Then we can say we have to take mod, so we will take number of v's to reach at v. This mod, okay, number of ways to reach at v is incremented by this. So but so since how was u relaxed, means u was relaxed with its distance, so distance from source of u and u was popped from the set. So shall I, so if there is a node which is not following this property, this property is not followed on this node, then what will happen? So can we say t dash shall we push it in the queue or not, in the priority queue or not? Because v should be pushed, because v, answer for v is known, so v should be pushed. Fine, so we can always insert st inside the set what the distance of v and v, right? But what if this v dash, so that this can be picked and this can again, because this v will never come back to u, is it so? Because from v, if it comes back to u, what it will so that will say that t, so that will have t plus v plus t plus t, so that means an increment of 2t in the capital T this much time, because from here I go to here, from here I go to here, from here I go to here, then I go to here, right? So 2t is incremented, so we will not come back to u again from this v once we have added the number of ways to v, and v can be picked later. So shall we add v dash or not? This is the question, right? Which v's to put, either this one which are satisfying this or everything. What if we put everything? Suppose I put this one also, so what it will say? It will say distance from source of u plus t dash, right? Plus t dash plus distance from destination of any other node v double dash is equal to t. Can it happen later? Yeah, it can, right? Because we don't know if there is any other node from this node. This might, so what happens? So from here will it happen? So that means it is v only and plus t dash. So from here, it can never update this one. Yeah, it cannot update some other v triple dash. Yeah, it can if this property holds. Because No, this might be possible to reach at this in t dash minus distance from source of u. Hmm. If it is not possible, okay. So what it is essentially saying that u, if that from that node b dash, it is not possible to go to the destination node in how much time? Capital T minus t dash minus distance from source of u, right? From u has two neighbors v and v. This v is possible. So this is t. This is t. This is t dash. So it is saying that this is not possible. That means t minus t dash. So that is property of this one. Okay, that means it is not possible to reach from this v dash to the destination in this much amount of time. It means from source I went to all the possible nodes, right? All the possible nodes. Then why to pick the non-possible nodes? Because we already know that from this node, if it is not possible from source already, so from that node, so why to pick that v? Sorry. So if I already know that it is not possible to reach the destination node from the v dash node using this path, so can there be any other path? Yeah, it can be, right? So maybe this u is not satisfying, but what if there is another u which is satisfying this? That means there might be this source from this path. Okay, this is one path that goes to destination. So I'm saying it is not, so say t dash does not satisfy, so in this path it will not be included, right? But what if this path has, then that will push v dash, right? So why to push prematurely? No, we don't push. So let's push only that satisfy. That means I can push v. I can push v. Which value to put now? Can we say st dot insert the distance from source to this node and this node. No, because this distance might not be coming from u plus t, right? We need to update it with u plus t, not v. because this is the new distance to reach here. Hmm. Is it okay? What did we say? Hmm. So from the source node, I went to these nodes to the neighbor from the source node with this distance, and distance from destination to reach is v is t. That means we can add the number of ways for v. We can increment the number of ways. But which node to process next? That's the question, right? So we said that we will always process such a node so that it don't have to be processed again. That means something has to be. Do we need to process? So if a node is not in my path, in the shortest path, so that will increment the answer by 0 only, right? Or that will not increment the answer. Yeah. So let's go with the Dijkstra one only. So that means let's have every node. Let's push every node. Okay. So go to all the nodes. See if the distance of this v node is greater than, so actually this logic only. So if distance of v is greater than distance of u plus t, then we need to insert it. But we need to have the distance vector ready. Distance to reach at node n is infinite, and we can say distance of the source is equal to 0. Yeah. Let's write this one. So while the set is not empty, we will find that you go to the neighbor. If that satisfies, then increment it, and then go to this node b is greater than this plus t, update it and push it, and finally what will I have? What will I have? The number of ways we need to return. The number of ways to reach at n-1 in t time, such that the number of ways to reach at the destination from n-1 is 0. Yeah. Okay, something wrong with this. So now what? Okay, adjacency dot size infinite. Okay, what's wrong now? So vector of pair of integer integer adjacency. Let's pass n also. So we have both these and so why did indentation go wrong? So while set is not empty, so distance from source. Cannot build range expression with the array. For neighbor or adjacency. Which line? Line number 22. Adjacency of u. Yeah. The number of wage. Okay, 52 is wrong. That means my logic is correct. Great. Why is it wrong? Expected is 0. Output is 0. Expected is 1. Everything is connected, right? So what if I have anything in integer? So int no t ll t. So it is ll. So vector of distance number of the vt and distance of v. Okay. Is this u and okay, t just the edge, so that is fine to write it like this. But let's say, so this distance from source is ll. Set of node and 0 while set is not empty. Is this the node and this thing this will work. Set of ll. And Why it is wrong there? Okay, 52 is passed, but it is same, right? 189 plus 7. Outside the representative value of long. Yeah, it will fail. 18 is the maximum value. 18 is the maximum value. And what's the error? Something wrong with this. What is long versus long int? Long versus long int. Unsigned long. Signed long. Okay, let's see. Unsigned only. When 26, will it work? I think it will not, because it will have 120 is 9. Int max, long max. Okay, long max. Does it exist? I'm just writing something. Okay, it exists. Fine. Long int max. Okay, it does not exist. What's the error, yaar? You long unsigned long max, unsigned long int. Type def signed long you long max. But I don't understand why it would fail. Not sure. But what I'm doing wrong. Let's see. So infinite is this. Okay, maybe by adding to the infinite it is overflowing, right? So maybe that is, so minus, let's say, so infinite is unsigned long int ll, sorry, gld unsigned long int is 1e17, maybe is 1e17 plus anything will not overflow. Still it is overflowing. 1e16, one e15. If not, I will find it out later in the tutorial. What's wrong, man? Number of wedge is 0, distance, and okay, I think here it might be the problem. It is LL, right? Yeah, got that problem. This one was overflowing. No, not this one. Distance, because 10 raised to 9 plus 10 raised to plus 10 raised to 2 into 100 means 10 raised to 12 can overflow. Okay, so it was a good question, man. Is it necessary to put everything, or we can only put, so let's test this also. So what if I don't put everything, but I'm going through that only? So let's put it only this one inside this one. If they hold, then only put. If they hold, then only put. Yeah, that will also work. Great. Nice question.